There is a patch of ocean between Hawaii and California, twice the size of Texas. It has no edges, no visible shape. Satellites can't see it. Ships sail straight through it without noticing, and inside it drift an estimated 1.8 trillion individual pieces of plastic, a number scientists only confirmed after realizing every previous estimate had been off by as much as 16 times. Nearly half of its total mass isn't bottles or bags. It's abandoned fishing nets, some of them decades old. And by the researchers' own measurements, it's growing faster than the ocean around it can absorb it. There's no storm that breaks it apart, no current that washes it ashore, nothing that would ever make it go away on its own. So what do you do with a problem that size? A team in the Netherlands, not a government program, one nonprofit, set out to answer that question. Join Breakthrough Engineering to find out what they tried. At 16, diving in the Mediterranean, Boyan Slat noticed an unusual amount of plastic drifting around him. It stayed with him. Chasing that plastic across millions of square kilometers of open ocean seemed impossible. So what if the ocean did the work instead? Currents already concentrate floating debris on their own. All it would take is a barrier that worked with that motion instead of against it. No giant fleet of ships, no fuel burned, just design. Back home in Delft in 2012, that idea became an 11-minute TEDx talk. For months, the video sat at around 2,000 views, forgotten, buried. Then media discovered it, and within days, it exploded. At that exact moment, Slat had $300 in his bank account. Within days, strangers around the world had sent him $90,000. He faced a choice: continue his aerospace engineering studies at TU Delft, or attempt something no one had built before. He chose the ocean. 2 years later, in 2014, a crowdfunding campaign for his new organization, the Ocean Cleanup, backed by over 38,000 people in roughly 160 countries, raised more than $2.15 million. One of the most successful nonprofit crowdfunding campaigns of its time. But $2 million doesn't build a system that can survive the open Pacific. So what does a nonprofit with no track record actually do with money like that first? So what does $2 million actually buy when nobody has ever attempted this before? Not a boat, not a barrier, not yet. It buys answers. Researchers from 7 countries joined the effort, running what became the most comprehensive survey of the Great Pacific Garbage Patch ever conducted, published in 2018 in the peer-reviewed journal Scientific Reports. 30 research vessels sailed through the patch. Behind them, crews towed 652 surface nets. Above, 2 aircraft flew survey campaigns, capturing more than 300 aerial images. Feeding all of it into computer models of ocean currents, the team combined methods that had never been used together at this scale. And for the first time, the true size and makeup of the patch came into focus. The number that came back? 1.6 million square kilometers. 3 times the size of France, twice the size of Texas. Sitting in that gap between Hawaii and California where no coastline exists to catch it. Its mass? An estimated 79,000 tons, with a possible range of 45,000 to 129,000 tons. 4 to 16 times more than every earlier estimate, though that multiplier applies to mass alone, not to the area or the number of pieces. Inside that mass, roughly 1.8 trillion individual pieces of plastic. That's 250 pieces for every single human being on Earth, concentrated into one patch of ocean. And here's what almost nobody expects. 94% of those 1.8 trillion pieces are microplastic, but they make up only 8% of the total mass. More than 75% of the mass is carried by larger fragments, over 5 centimeters. This isn't a floating island you could stand on. It's invisible to satellites, barely visible to the naked eye, with no fixed edge or shape, constantly reshaped by wind and current. And the biggest surprise of all? 46% of that mass is fishing nets. Not bottles, not straws, not bags. Nets, lines, and ropes abandoned by the fishing industry make up an estimated 75 to 86% of all floating plastic mass out there. Once UV light breaks that plastic down into fragments smaller than a grain of rice, it's already been found in fish, shellfish, sea salt, and drinking water, entering the food chain through plankton and climbing from there onto dinner plates around the world. By 2018, SLAT's idea had become steel and plastic, System 001. The crew nicknamed it Wilson after the volleyball that keeps Tom Hanks company in Castaway, because, like that volleyball, this barrier would be drifting through the Pacific completely alone. It took 6 months to build in a shipyard in Alameda, California, a 600-meter floating pipe welded together from sections of HDPE, tough enough to survive the open ocean, yet flexible enough to bend with the waves instead of cracking under them. Hanging beneath it, a skirt reaching roughly 3 meters underwater, built to catch plastic drifting just below the surface, not only what floated on top. Bent into a giant U and towed into the patch, the plan was for it to work almost entirely passively. No engines, no propulsion, just drifting with wind and current, letting the same forces that concentrate the garbage patch push plastic straight into the mouth of the U. Deployed in September 2018, it worked. Almost. Plastic drifted in, as designed. Then, in December, an 18-meter section of the pipe broke away, a fatigue fracture at the weld joining the floater to its skirt, where tiny gaps had quietly built up stress every time the system flexed in the waves. After 4 months offshore, having collected just 2,000 kilograms of plastic, Wilson was towed back to Hawaii at a time when many marine scientists already doubted the concept could work at all. But the failure revealed something the team had missed. The U-shaped barrier itself wasn't the flaw, its speed was. The system had to move slower than the plastic itself for debris to gather inside the curve instead of drifting past it. That single insight, not any new material or technology, was the real breakthrough, and it wasn't the last one. Every setback that followed got folded straight back into the next design, carrying the project step by step to the system now working the Pacific today. Today's system, System 03, stretches about 2.2 kilometers with a collection screen reaching 4 meters underwater, towed between 2 ships using AI-guided navigation toward plastic hotspots, 3 times larger than System 002, which alone removed 250,000 kilograms between 2021 and 2023. Onboard cameras and a safety system called MASH detect marine animals and let them escape the collection zone before it closes. Cleaning the entire patch would take roughly a dozen installations this size. System 03 is the blueprint for all of them. On land, solar-powered river barriers called interceptors stop plastic before it ever reaches the ocean, since a relatively small number of rivers account for a large share of what flows in. Newer tools are already being tested. A 1:10 scale model at the Marin facility in the Netherlands, AI-equipped drones in South Africa spotting plastic from kilometers away day or night, and a logging system called ADIS that makes each mission smarter than the last. Some of the recovered plastic becomes sunglasses and industrial products, including a partnership with Kia, though much of the oldest ocean plastic is too degraded by UV and saltwater for high-quality recycling. By the Ocean Cleanup's own count, they've removed roughly 46 million kilograms of plastic as of late 2025, with a stated goal of clearing 90% of floating ocean plastic by 2040, a target the organization itself estimates could cost billions of dollars. A dozen systems the size of System 03, running for years against an accumulation zone that keeps growing before any of them even launch. The Ocean Cleanup calls this a football field of plastic cleared every 5 seconds. And by their own estimate, finishing the job could still cost billions of dollars. Do you think the ocean can be cleaned faster than it's polluted? Or does the real fix have to start on land before plastic ever reaches the water? Let us know in the comments. And if you want to keep exploring the world's greatest feats of engineering, join Breakthrough Engineering for the next one.